Okay, today we're going to learn how to solve systems by substitution. This is a new method, but remember, we're not afraid of new methods. It's just a different tool for us to use. So the first method that we used was graphing, right? And I like ice cream, so I consider this to be the ice cream of my my systems. So if I was graphing we consider that our ice cream scoop. Okay. Now, if graphing doesn't work, so maybe I use graphing when I have two equations that are in slope-intercept form. So let's say I have two equations that have x by themselves, or when I try to put them in the calculator in slope-intercept form, when they're in y equals mx plus b format, I get a weird answer. Well, then I'm going to get a more fine tool. I'm going to use setting equal, which is a spoon, right? Because I can get a little bit more close to what I want if I use a spoon. Okay, now we're going to get a new tool, a completely different tool for a completely different situation. This doesn't have anything to do with ice cream. Now maybe I'm digging a hole in the backyard, okay, and now I need a shovel, so I need a different tool, okay. So the tool that I'm going to use now is called substitution, okay. I use this tool when I have one equation with an isolated variable and one equation that's not isolated, or it's a different variable. Okay, so this is a good example. I have an equation in standard form and I have an equation in slope-intercept form. Well, I could convert this into slope-intercept form, but that's a lot of work. I have a method that I can use that allows me to leave these like they are and not have to do any extra math. Remember, every extra bit of math we do is an extra chance to make a mistake. We don't want to do that. Okay, so the way this method works is we're going to start off, we're going to look at what variable is isolated, and we're going to find that variable in the other equation. We're going to circle whatever is on the other side of the isolated variable, and we're going to draw an arrow pointing to where we're going to substitute it. Okay, so we have y equals 5x plus 6, so anytime I see a y, I'm going to put 5x plus 6. And then I'm going to actually rewrite this equation with 5x plus 6 in place of y. So I have 2x minus 3, and I got to a y, so I'm going to put 5x plus 6 in its place, and then I'm going to keep going. So all I've done here is 2x minus 3y, which is 5x plus 6, equals 60. I just rewrote it with 5x plus 6 in place of y. Okay? Now I'm just going to solve it. Okay? Okay, it's time for me to go, but that's okay. 2x is a leftover. I didn't do anything to it, so I just bring it straight down. I need to distribute this negative 3. Remember, the negative is part of what I'm distributing, so make sure you don't forget that. Negative 3 times 5 is negative 15x. Negative 3 times 6 is negative 18. I hit the equal sign, so okay, I get it. So I stop distributing, all right? Now equals 60. This comes straight down and that comes straight down because I didn't do anything to them, okay? Now I'm going to keep going. I'm going to start combining my like terms. Well, I have a negative 15x and a 2x. Well, 2 minus 15 is negative 13x. Minus 18 equals 60. Remember, I can't combine across the equal sign. So for that, I'm going to have to add 18 to both sides. Okay. Negative 13x equals 78. I want to divide both sides by negative 13, and I'm definitely going to use my calculator symbol for this. 78 divided by negative 13 is negative 6. So x is negative 6. Now from here, I do the same thing that I did before. Okay, I've solved the equation. I know what x is. And the reason why I said solve the equation is because I might be solving for x, I might be solving for y. Well, I'm going to take what I solved for and substitute back in. So I'm going to go back to, I think this would be an easier equation. So I'm going to substitute into my isolated variable. I'm almost ready. I'm going to substitute, just give me a minute. I'm going to substitute into my isolated variable. I have y equals 5 times negative 6 plus 6. Well, that's negative 30 plus 6, which is negative 24. Okay, I think my answer is negative 6, negative 24, but I'm going to use my final equation here to find out. 2x minus 3y equals 60. 2 times negative 6 minus 3 times negative 24 should equal 60. So let's see if that works out. 2 times negative 6 minus 3 times negative 24. Okay, that's not, I entered that wrong. Okay, hold on, let me get rid of that, let me fix that. equals 60, just like I wanted to. So that means I've done it correctly. So my ordered pair, remember the last step is to write it as an ordered pair and a coordinate, is -6, -24. All right?